Welcome back for part 2 of section 5.5, integration by substitution. Alright, so here we are. We're doing examples of integration by substitution. Here is our latest example. My job is to find the integral of the quantity x cubed multiplied by the function cosine of the quantity x to the fourth plus 2. Alright, so the first thing I recognize here is I'm looking at two things being multiplied together. One of them is composition. The other appears to be the derivative of the inside of the other. Kinda, sorta. All right, we'll see if we can make this work. All right, so the first step is, once I recognize what to do, start by defining u to be that inside piece of the composition. And then we do that differentiating business, so we get du dx is equal to 4x cubed, or du is equal to 4x cubed dx. And now I need to do the substitution, but I've got a problem. Do you see the problem? The substitution that I'm supposed to make is I am supposed to make the substitution 4x cubed dx for du, but my integrand is missing that 4. But that's okay. With a little bit of algebra, I can take this line right here, divide both sides by 4, and say that 1/4 du is equal to x cubed dx. And now I have the piece that I need to have to do the substitution. This right here that I just did, this step of modifying, if you will, through algebraic manipulation for a missing coefficient, and I'm going to say that again for everyone, the only thing that you can modify for is a missing coefficient. If you're missing a missing addend, like if it needs to be +3 and it's not there, you can't fix that in this way. You can't just add 3 and call it okay. All right, that's going to be a problem that we'll deal with in a different way. Right? You can fix for a missing coefficient by just simply doing algebra on that du line that I have boxed out there in purple. On this line right here, you can fix for that missing coefficient. Okay? Now that I've got the u picked and I've got the du figured out for the substitution, I can actually do the substitution. So now by substitution, this becomes the integral of the cosine of u times 1/4 du. Okay, I'm going to highlight in yellow here what got replaced with u, and then highlighted in pink is already what's going to be replaced with the 1/4 du. Okay, you'll notice that cosine is still there because cosine did not get substituted out. Nothing over here in our work, our scratch work over here to the side, ever mentions cosine. Right? The outside part of the composition doesn't get substituted out. It's the inside part of the composition that gets substituted out. Now, if I've done everything correctly, this integral right here, two things should have occurred. One, all of the original variables, x in this case, will be replaced with u's, so there are no extra x's floating around in my integrand. And two, the other thing that should have happened is I should now have something that I can relatively easily integrate. I know the antiderivative of cosine, so I can do that. The 1/4 is just a coefficient, so it'll just stay there. That's that 1/4 right here. Right? The antiderivative of cosine of u is going to be sine of u, and of course plus c because we're doing an indefinite integral. Now again, I am not... Excuse me. Wow, that came out of nowhere. I am not done because this variable right here is unacceptable. The original variable from the original problem was x, so my final answer has to have x's in it. So I will do a back substitution and replace x with what we defined it to be in the substitution. In this case, x to the fourth plus 2 plus c. Again, if I was unhappy with this, or if I was concerned that this was the correct solution, I would just simply take the derivative of that to make sure it works. So the derivative, if I differentiate this with respect to x, I'm going to have 1/4 times the cosine of x to the 4th plus 2 multiplied by the derivative of this, which would be 4x cubed. The 1/4 out in front and the 4 are going to cancel, and that's just going to give us our x cubed times the cosine of x to the 4th plus 2, which is our original integrand. Right? Integration by substitution. Step 1, recognize that it is substitution. Recognize that you have two things being multiplied together. One of them is composition, the other is the derivative, or most of, the derivative of the inside part of the composition. Identify the inside part of the composition as your u statement. Calculate du by using differentials. Once you've got du figured out, do your substitutions. Modify du if necessary, and do your substitutions. Right? More examples. All right. So here we go. I have an integrand. It is x divided by the square root of 1 minus 4x squared. Now you might be thinking, hey, wait a second. You just got done saying that it has to be two things multiplied together, and now you're simply saying, wait a second, this is divided by. All right, remember, I can always rewrite my integrand using algebra. So I am going to rewrite this and say that this is equal to x times the quantity 1 minus 4x squared to the negative 1/2 dx. And now when I look at this, I see two things multiplied together. There's the x dx, and then the other one is this guy. And that is definitely a composite part of this integrand, or the composite multiplicand of this integrand. So now I'm going to think, well, if I have two things multiplied together and one of them is composition, probably going to need substitution to make this work. So then over here on the side with my scratch work, I am going to say that u is 1 minus 4x squared. Remember, we always define u to be the inside part of the composition, and then we go from there. Okay? Calculating differentials and all that, I get that du is negative 8x dx, and then I check to see if that matches what I was given in my integrand. And it doesn't. My integrand just has x dx, what's highlighted there in pink, and my du needs negative 8x dx. Well, this is the same problem I had a moment ago. I'm just going to fix it the same way. Divide both sides by that negative 8, and I get negative 1/8 du is equal to that x dx, and now this matches what I have over there, so I can do my substitution. Okay? So once I've identified everything, I will perform the substitution. My new integrand is now going to be the integral of u to the negative 1/2 times negative 1/8 du. Right? I'm not worried about this, just like I wasn't worried about that 4 a moment ago. It is just a coefficient. It'll just be in the answer. Other than that, the two things that are supposed to happen in composition happened. This is something that I can easily integrate, and all of the variables that used to be x's are now replaced with variables u. So I'll perform the integration. It's going to have that negative 1/8 coefficient, because that's just going to drag along through this. The antiderivative of u to the negative 1/2 is going to be, let's see, add 1 to the exponent gives me 1/2, so that's going to be 2 over 1 times u to the 1/2, and of course plus c. Now, two things are wrong with this. I need to clean this up, and I can't have u's in my final answer because my indefinite integral was handed to me with the variable being x. So I'm going to clean that up and do a back substitution in one step. That's going to give me negative 1/4 times the quantity 1 minus 4x squared to the 1/2, and of course plus c. Now some people will make the following argument, that since the original integrand was written using radical notation, since the original integrand was written using a square root symbol right there, that we should write our final answer using a square root symbol. And we should go, this is the negative square root of 1 minus 4x squared over 4 plus c. Now I will ask you this question. Is this the same thing as this? So unless for some reason the directions told me I had to do that, I don't see any reason to do that. I can accept either one of those as being the same, essentially. Okay? All right, moving right along. Here's our next example. Okay? Now this one's a little trickier because we have to be able to see something in a way that we normally don't see it. Okay. So if we consider the last one like a medium problem, then this one would be a hard problem. First thing I'm going to do is I'm going to rewrite this, because although this is not algebraically incorrect to put the squared there, this problem is going to look a lot better if I rewrite it more algebraically correct. Okay. All right, so here's the challenge that you're going to see with this one. Many people will look at this and say, hey, this is composition, and this is composition, and that makes it also composition. So what do I do? How do I make this one work? Because if I try to say this, if I try to argue that this is my composition for substitution, then I would say that u is 3x. I would say then that du is 3 dx. But if I did those substitutions, and I'm going to write this out and then I'm going to erase it because it's wrong, my problem turns into this. And that didn't fix anything. So that must have been the wrong choice for you. So I'm going to look at the largest composite and think of that as my composite part of this. And if that's my composite part of this, then the inside piece, the u, is going to be the entire expression sine of 3x. And then my differential du is going to be cosine 3x times 3 dx. Okay, remember, chain rule applies here. So when I take this derivative of the sine of 3x, I get cosine 3x and a 3. Okay? Now if I look back at my expression that was handed to me, I'll see that I have most of that du sitting right here. What's missing? Well, the 3. So I'll do the same thing that I've done for the last two problems. I'll make that division happen. And I get cosine 3x dx, and now I can perform the substitution. When I do the substitution, that integral turns into u squared times 1/3 du. Big and ugly, small and pretty. All this ugliness with substitution turns into something that is super easy to do. I do my substitution, the 1/3 is a coefficient it drags along. The antiderivative of u squared is going to be another 1/3, but this time u cubed. And of course, it's an indefinite integral, so I do a plus c. Right? Two things are wrong with this. I need to clean up this algebra, and I have to do a back substitution on u. 1/9 from the algebra, and the sine of 3x cubed plus c. Now, of course, I know there's at least one person out there who's thinking this. Could you do this then? Absolutely. If that's what you feel you need to do, you can do that. Okay? All right, so substitution. Substitution, substitution, substitution. It is one of the single most common applications of integration or techniques for integration that you're going to run across in calculus. Trust me when I say this, it's hard, but as you do it more and more, it will become easier and easier, and you will get to the point where you can actually start doing all of this in your head, and you'll be able to go directly right to there. You'll just be thinking, oh, that's my u, there's my du, I'm done. Okay? Right. I've got 1, 2, 3, 4, 5, 6 more before we do definite integrals. So we're at 15 minutes here. I will do one more on this video, and then we'll make a third video. Okay. Now what you may have noticed is the problems are getting harder. Right? Here is a great example of a substitution problem that does not look like a substitution problem. Because one of the things that I kept hammering on when I was defining substitution in video 1 was your integrand needs to be two things multiplied together. And this integrand only has one term. Okay? So here's the pattern recognition that we have to see. That our one term is composite, and the inside part of this one term that is composite is linear. And that's going to become very important here in a second. But that inside is linear. And here's why it's going to become important. If we recognize that as composite, we would say that u is 2x plus 1. And then our differential du would just be 2 dx. And do you see how when we took the derivative and got our differential du, that suddenly the variable disappears? So now, with a little bit of algebra, I can say that 1/2 du is just dx, and now this will substitute out. I'll perform my substitution. I get the integral of u to the 1/2 times 1/2 du. Okay? This is right there. The dx is right there with the 1/2 du, and my integration is done. I'm sorry, my substitution is done. My integration is done. I haven't integrated yet. Now I'll integrate. The 1/2 as a coefficient, so it just drags along. Adding 1 to the exponent gives me 3/2, which means I need a coefficient of 2/3. And of course, it's an indefinite integral, so we get a plus c. I'm going to multiply those two together, do a substitution there, and I'll be done. Let's see, what's 1/2 times 2/3? That's going to be 1/3 of the quantity. And what was my u again? Oh, yeah, that's right. It was 2x plus 1, right? Raised to the 3/2, and of course, plus c. All right, that looks good to me. So, how did this one work again? Because it didn't look traditional. If you think back to every other problem we've done so far, every other problem, the original integrand, two things multiplied together, two things multiplied together. Two things multiplied together when we rewrote it. Two things multiplied together. Uh-oh, it's not two things multiplied together. And why did it work still? Well, it works still because the composite part of this that we could easily see, because it was sitting right there, the inside of the composite was linear. If the inside was not linear, this probably wouldn't work, and we'd have to do it some other way. Right? Now, this same problem, this same issue, the same concern with this inside linear is right here too. Do you see it? Okay. The e to the 5x is the composition here. This is composite. Because it's not just e to the x, it's e to the 5 times x as you do a function. But that inside part of this thing, the e to the, is linear. Okay, that's linear. So if we say that the inside u is 5x, then our differential du is just 5 dx, or that 1/5 du is dx, and now I've got the substitution for the dx. Perform my substitutions. This becomes the integral of e to the u times 1/5 differential du. The 1/5 is just a coefficient, so it drags along. The integral of e to the u, love it, e to the u, and then plus c. Okay. What's still wrong with this? Well, I can't have a u in my final answer, so I will do a back substitution, and I get 1/5 e to the 5x plus c. And I'm done. I'm going to call this video right here because we're at 20 minutes, and we'll come back and do some more in the next one. Hopefully that all made sense.